All right, so these are the notes for graphing quadratic functions in vertex form. So here we have the vertex form f of x, which is y, equals a, parentheses, x minus h squared plus k. Okay, so once again, if a is positive, so this number in front of the parentheses is positive, the graph opens up. And if it is negative, just like before, it still opens down. Now for the vertex, we're going to get that from h and k. So for this right here, h, for the vertex, you're going to take the opposite of that. So the opposite is h. And k, it is what it is. So it's just positive k. So if it was -3, it'd be -3. 4 is 4. If this was x minus 3, it would be positive 3. If this was x plus 7, it would be -7. And just like before in standard form, your axis of symmetry is actually the h value of the vertex. So in this case, x equals h. So you could pretty much take x minus h, set it equal to 0, and solve it, and you would get x equals h. All right, now for transformations, it's pretty much what we've done in the past, right? So this is our a value right here. Notice it's in front. It's the coefficient. So if a is greater than 1, that's going to be a vertical stretch by a. If a is less than 1 but greater than 0, that's going to be a vertical compression by a as well. Okay? And also if a is less than 0, so it's a negative number, not really the constant, but just that negative sign, it reflects across the x-axis. All right, from here we're going to have the h value, which moves it left and right. And once again, what we see is the opposite. So if I see x minus 3, that moves to the right 3. If I see x plus 4, it moves to the left 4, because really the h is the opposite of what you see in there. And then last, we have the k value, and that's going to move your graph either up or down. So the k value moves it up or down. And this one's pretty easy. If k is greater than 0, it goes up. If k is less than 0, it moves down. And let's keep this color coordinated here. So I'm going to change this really quick just using blue. It's not like it's going to matter, but I will do that. Left or right. Okay, so those are our transformations right there. So notice we can see a lot just from this type of form right here. Okay, the next thing we have is the example. So this is, once again, it's a quadratic function. The reason I know that is because it is squared right here. We can see it's squared. So we have an a value of 2. So let me just write this out. I'll just pick, we'll just use green. So the a value is 2. H is the opposite of that, which would be 3. And k is 4. So that's just identifying a, h, and k. And once again, I know this is a quadratic function because it is squared. All right, for my vertex, we see that it is h comma k. So h opposite of that is 3, comma k is positive 4. For my axis symmetry, x is equal to h, so x is equal to 3. And pretty much you could just take that equal to 0 and solve it, so x equals 3. Now for my direction, it's either going to be up or down. So if a is positive, it goes up. If a is negative, it opens down. So in this case, a is a positive 2, so we know it opens up. Now for the roots, I'm going to go ahead and get that from the graph. But let's go ahead and see. It says describe the transformations that occur to the parent function to produce the graph. So first we're going to look at a is 2. So a is greater than 1, so that's a vertical stretch by a. So this one would be a vertical stretch by 2. Right here, it's the opposite of what we see. So instead of saying left, it actually moves to the right 3, because the h is positive 3, so that moves to the right 3. And then last k is positive 4, so it moves up 4 units. All right, now for the table, we're going to put this in the middle here. So let's see if I can draw this table a little bit darker and nicer so you can actually see it. All right, and that's the best I can do there. So now let's go and take a look at this table and see where the values do go. So I like to put the vertex in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5. So 3, 4. So 3 and 4. Numbers getting bigger than 3 are going to be 4, 5, 6, 7. Smaller, 2, 1, 0, negative 1. Now for here, pretty much what I'm going to do is I'm going to plug these x values inside of here and then work it out. Okay, so the first one right here, I'm just going to 2 parentheses, x is going to be 4 minus 3 squared plus 4. So 4 minus 3 is 1. 1 squared is 1. So 2 times 1 is 2 plus 4 is 6. Then I do the next one. 2 times 5 minus 3 squared plus 4. So 5 minus 3 is 2. 2 squared is 4. So 2 times 4 is 8. 8 plus 4 is 12. And we're just going to keep going. 2 times 6 minus 3 squared plus 4. 6 minus 3 is 3. 3 squared is 9. So 2 times 9 is 18. 18 plus 4 is 22. And then the last one we have is 2 times 7 minus 3 squared plus 4. 7 minus 3 is 4. 4 squared is 16. 16 times 2 is 32. 32 plus 4 is 36. All right, and then we know that this is a vertex, so every point reflected across would be the same. So 2 would be 6, so 6, 6, then would be 12, 12. It would be 22, 22, and 36, 36. All right, from here I'm gonna make my graph. So we're gonna start at 1, 2, 3, 1, 2, 3, 4. And then I'm gonna go to 4, 6, 5, 6, and 3, 6. And past this point, 5, 12 goes off the graph. So I'm gonna make my best way to just graph this here. So I have this here and that there. And now we can see that the graph does not actually cross or touch the x-axis. So for in case of the roots, that's going to be a no solution. Now we're also going to talk about how to convert from vertex form into standard form next. So we still do have a few more examples we'll talk about really quickly. We're going to go through what we need to, then we're going to graph them and talk about maybe even the domain and range as well. All right, so for here, transformation. So I'm looking at this here. I know it's vertex form again because I can see A, there's no number, so I'll put a 1, so I know A is 1. H is the opposite, so x minus 1 equals 0, x equals 1, so H is 1, and K is negative 3. Don't forget that sign in front for K. So for transformations, A does nothing, but this is right 1, and this is going to be down 3. Axis of symmetry. I'll do the vertex first. Whenever you do vertex form, always do the vertex first. So H, so opposite of that is 1, comma K, which is negative 3. And we know that the x value of the vertex is also the axis of symmetry. So in this case, x equals 1. Don't forget the x equals because it is an equation. For the direction, we look at A. A is a positive 1, so it opens up. Roots we'll talk about in a sec, and we'll also talk about the domain and range and how to convert it to standard form. So first off, we're supposed to start the vertex, and we're going to go right 1, and notice this is going by 2, so right 1 and up 1, 2, 3. And then from here, we just plug in numbers to get our graph here. There is also a shortcut, and if you want to know how to do that, I can show you, but I'm going to stick with just currently this right now, and I'll show you my shortcut in a sec. So I make a table. So we put 1, negative 3 in the middle. So bigger numbers 2, 3, 4, 0, negative 1, and 1. Sorry, negative 1 and negative 2. And so we just start by plugging numbers in. So we'll start with the number 2. So 2 minus 1 squared minus 3. 2 minus 1 is 1. 1 squared is 1 minus 3, which is -2. Okay. From there, we'll do another one. I'm going to go ahead and erase this here. And now we'll start with the value of 3. 3 minus 1 squared minus 3. 3 minus 1 is 2. 2 squared is 4, so 4 minus 3 is 1. Okay, and then the last one. And then we can reflect these numbers onto the other side of the vertex. So now we have 4. 4 minus 1 squared minus 3, so 4 minus 1 is 3. 3 squared is 9, and 9 minus 3 is 6. And then we can just flip these over. So this should be -2, 1, and 6. Okay. So that's how I did the work there to get these points. So let me go ahead and now take a look at when I graph this. So we start with 1, -3. So 1, 2, -3. Here we have 0, -2. We have -1, 1, and we have -2, 6. I'm not sure where that point's there. Then I have, let's see, I have 2, -2, 3, 1, and 4, 6. So here you can see the root is not exact. And there are ways to find that root. So we're just going to estimate it here. So the root appears to be -1/3, 0, and it could very well be -1/4, 0. And I'll call this one, sorry. This is going by 2s, so if this is -1, I'd say like, I mean, it's pretty close to -1. So we'll just call this -1, and we'll call this one 1, 2. We'll call this one 3, 0. Now these are not exact. Later on we'll get how to actually solve these to get the exact roots, but for right now it's just an estimation. If I wanted to do my domain, so let's say I wanted to do my domain, it's from this bottom number, or sorry, it's going left to -infinity, right to +infinity. And for my range, bottom is at -3. That's a closed circle, so it's a bracket, and these head towards infinity. Now, to convert it to standard form, first what we're going to do is leave the a value alone, and then this squared, we're going to write x minus 1 twice. So x minus 1 times x minus 1, and then don't forget your minus 3 over here. Then we're going to go ahead and FOIL this out. So x times x is x squared. Let's put y equals. X times -1 is -x. Now we distribute the -1. -1 times x is -x. -1 times -1 is +1. Don't forget your minus 3. From here, we combine like terms. X squared minus x is minus 2x. And then 1 minus 3 is -2. And now it's an ax squared plus bx plus c form. So my standard form is y equals x squared minus 2x minus 2. Okay, on to the next problem. So really quickly, let me kind of talk to you about the pattern that I use to graph these, and I'll probably graph the next one the way I would do it. So if you ever look at the parent function of the square root, so let me just go ahead and write that on the back of this paper right here. So if you think about it like this, if y equals x squared, and I'm just going to put some values here, -4, -3, -2, -1, 0, 1, 2, 3, 4, sure, I'll go to 5. So what we do is we square each one. So -4 squared is 16, -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, and 1 squared is 1, 4, 9, 16, and 5 squared is 25. So now there is a pattern that actually takes place. So this is the vertex right here. And from the vertex, how do you get from 0 to 1? Whether you go up or you go down, you'll both notice it's 1 unit. To get from 1 to 4 is plus 3 units. 4 to 9 is plus 5, plus 7, plus 9, and so on. So you see it's 1, 3, 5, 7, 9. So if your a value equals 1, this pattern of 1, 3, 5, 7, 9 is what you can use to make the graph. And I'm going to show you how to do that right now. Now, if your a value like in this next one, it's going to be a negative, right? So we can see that negative reflects it across the x-axis. So all you would have to do is multiply all of these numbers by -1. So when you apply this, you would get -1, -3, -5, -7, and -9. Now I'm going to show you how to apply this right now and how this actually works. So let's take a look here. I'll also do the table because tables are something that everybody can build. And you can also type this in a calculator, but just in case you are curious how to graph this by hand. So we just talked about the negative reflects it across the x-axis, which makes it face down. And this is left 9. It's the opposite of what we see. Now, you'll notice there is no k, right? So there is no plus some number or minus some number, so it would just be positive 0, right? So the axis of symmetry, opposite of that is negative, or is x is equal to -9. And pretty much you could take x plus 9, set it equal to 0, and you would subtract 9, and that's how you get x equals -9. Then we do the vertex, so opposite of that is -9, comma k, there's no k value, so it's 0. So -9, 0 is your vertex. The direction, A is negative, so now it faces down. Okay, so here we can graph -9, 0, which is right here, right? And how would I do this? So if I were to use the 1, 3, 5, 7 rule, what happens is you always go right or left 1 unit. So I always prefer just to go right 1. And then the A value should be 1, but since it's negative, you go down 1. So from that point, we have that new point right there. From that point, we go right 1. And if our A value, if you look back over here, it was supposed to be 3, but we multiply by -1. So instead of going up 3, we go down 3. So 1, 2, 3. And now my next one should be 5. So from that point I just made, I go right 1 and then down 5. 1, 2, 3, 4, and 5. Then I can reflect these across over here. But we're going to run out of room. So let's kind of see how this works out on the table, right? So I always make a table. And my vertex is -9, 0. So -8, -7, -6, -10, -11, -12. Okay, so from here, let's go ahead and take a look here. We're going to plug in numbers. So we're going to start with -8. So negative parentheses -8 plus 9 squared. So -8 plus 9 is 1. 1 squared is 1, and that becomes -1. All right, so, and you can look, -8, -1, that point worked out. So I'm going to erase this and plug in my next value. So now we'll plug in -7. So -7 plus 9 squared. -7 plus 9 is 2. 2 squared is 4, and that becomes -4. So if we go to -7, so 4, 5, 6, -7, then we go 1, 2, 3, 4. You notice it falls right on the dot. Okay. And I'll just verify this last one with the -6 here. So we have negative, and then we have -6 plus 9 squared. -6 plus 9 is 3. 3 squared is 9. That becomes -9. And you can see here, if we go to -6, and we go down 1, 2, 3, 4, 5, 6, 7, 8, and -9. So you see it does work out nicely. And I can reflect these, and there's my graph. And once again, just try your best to make the graph. I am not the best artist, but I do try my best there. For this root, it's pretty easy to see. It's called a double root because it hits if there were two solutions, it would be the same solution when you solve it. So we can see it hits there at -9, 0. So those are my only roots. For the domain, since there are no restrictions, -infinity, +infinity. For my range, though, it starts at the bottom, right? These head towards -infinity, and they come to the top, which is at the y value of 0. And we talked about this before. If it's the highest point, that is a maximum, and my maximum value is the y value of the vertex. In this case, would be 0. Over here, this would be a minimum because it's the lowest point, and my minimum value would be the y value of the vertex, which would be -3. So just kind of refreshing y'all on that. Now to convert this to standard form, just like before, keep the a value there. We're going to write this x plus 9 squared, so we're going to write it twice. And we leave the negative alone, then we FOIL this out. X times x is x squared. X times 9 is positive 9x. 9 times x is 9x. 9 times 9 is 81. And then we combine our like terms. So x squared, 9x plus 9x is 18x plus 81. And now we distribute this. Negative x squared, negative 18x, and negative 81. And that is my quadratic function in standard form. Now we're down to this last question here. It says, consider this function right here, negative 10, parentheses, x minus 5 squared plus 7. Describe the transformation of the graph of the parent quadratic function, then identify the vertex. So it's asking us to identify the transformations. So this first is this negative sign right here. That negative sign reflects it across the x-axis. So that's number one. Number two, we have this value of 10. That value of 10 is greater than 1, so that is a vertical stretch by 10. This x minus 5 in the parentheses, it's going to be the opposite of what we see, so it's actually going to the right 5 units. And then for the last transformation, we have this positive 7. That's the k value. It's greater than 0, so it goes up 7 units. And then last but not least, we already know that the vertex is opposite of this, so x minus 5 is actually a positive 5, so h is positive 5, and k is what it is here, so that's positive 7, so it goes 7. Oh, I put an h there instead of a 5. Hopefully you can recall that if we went at the axis of symmetry also, it's just the x value of the vertex. And that completes the notes. And just in case you're curious of how you can plug these into the calculator, so I have Desmos here. And I'm just going to take these equations and just kind of show you that you can plug these into the calculator as well to kind of get all the information I have here as well. So let's put this here. So if I like this first one, so I have it open, so parentheses, x minus 1, close parentheses, squared, minus 3. And you can see if I take a look at my graph, so it went right 1, 3, down 3, you can see that it's the same thing. Except mine here is going by ones, this one went by a scale of 2, just in case you didn't notice that. So you can see the graphs are relatively the same. Okay. And then over here in number 2, I'm going to type this one in as well. So let's go ahead and say negative, parentheses, x plus 9, close parentheses, square. Oh, I didn't square it. There we go. So we take a look at this here. You can see it's moved over there to the left, and over here, if I move it, we can all see it. The vertex is at negative 9, 0, and it's facing down just like that, and we can see our graph is doing the exact same thing. So you can also type these into Desmos, and that's how I did it.